Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce.
Hello students, I am Mr. Salami E.A. Welcome back to physics class. Today we are going to take a look at dimensions of physical quantities. Yes, we have discussed about fundamental and derived quantity before. Then let us take a look at their dimensions before we now look at what the uses of such dimension. Then dimension of physical quantities are expressed based on three fundamental quantities, which are length, mass, and time. And when we get to the dimension, what we are going to make use of, not the word here, is the letter, the abbreviation, which is L, M, and T. We are going to make use of. Then the quantities and their dimension are summarized in the table below. Now let us take a look at it. We have quantity, we have the definition of such quantity, and we have its interpretation. Then length. Length is the measurement between two separated points. Then the dimension of this, the interpretation of this, we have it in what? In L, which is length, L. And the dimension of length is also given to us as what? L. Then look at area now. We have length multiplied by what? Breadth. What's the dimension? What's the interpretation of length here? Is still L, because it is measured in meter. The breadth here is also measured in meter. Therefore, its interpretation is also what? L. And when you multiply this and this together, that is the L here multiplied by L, what we are going to have here becomes what? L squared. That is L raised to power 2. Because the length here, L here has a power of 1. The L here also has a power of what? 1. Then when we are considering the indices, the power now, according to the law of indices, you add the power here to what? This other power we have here, which is what? 1 plus 1. What we are going to arrive at is what? 2. Therefore, we have it as what? L raised to power 2. Which shows that what? The dimension of area now becomes what? L raised to power 2. Now, let us look at what? Volume. The definition of volume here now, that is the expression of volume. We have it in what? Length multiplied by breadth multiplied by what? Height. Length is measured in meter. Breadth is measured in meter. Height is also measured in meter. They have the same what? Dimension. That is why we have it in what? Length here, which is L multiplied by L multiplied by what? L. When you multiply the three length here now, the three L here now, what we are going to have here now becomes what? L raised to power 3. Because the power of L here is 1. The power of L here is also 1. And the power of L here is also what? 1. 1 plus 1, 2 plus 1, we have it as what? 3. Therefore, the power of L we are going to have here now becomes what? 3. We have the dimension of volume to becomes L raised to power what? 3. Now, let us take a look at velocity. Then the velocity is what? Is the displacement all over time. Displacement also measured in meter, while time measured in what? Second. Then the dimension of what? Displacement now becomes what? L. While the dimension of what? Time is what? T, capital letter T. Then we have it as what? L all over T. Then if you want to change this now, T here now is same thing as what? L all over T is same thing as what? L multiplied by what? 1 all over T. That is inverse of what? T. Then according to law of indices, if you are having inverse of what? T now, inverse of any letter now, it becomes what? That letter raised to power what? Minus 1. Therefore, multiply T raised to power minus 1 by what? L here now, we have what? L T raised to power minus 1. Therefore, the dimension of velocity now becomes L T raised to power minus 1. Now, let us look at acceleration. Acceleration is the velocity all over time taken. Velocity all over time. The dimension of velocity now, we have done that before, which is what? Lt raised to power minus 1. Wherever you see velocity now, put what? Lt raised to power minus 1. Why the dimension of what? Time taking is what? T. Time taking is T. This T here now is same thing as T all over 1. T divided by 1. Then if you want to change this sign of division to multiplication, 1 will go up and T will come down. That is why we have what? 1 all over T, or inverse of what? T. When you multiply inverse of T now by this now, what we are going to have here now becomes what? This 1 over T now is same thing as what? T raised to power minus 1, as we have under velocity here. And minus 1 is here, minus 1 is here. When you add minus 1 and minus 1, what you are going to have there becomes what? Minus 2. That is why we have what? LT raised to power minus 2. Then LT raised to power minus 2 becomes the dimension of acceleration. Dimension of acceleration. Now let us look at what? Force. Force is the product of mass and its acceleration. That is why we have mass multiplied by acceleration. Then what's the dimension of what? Mass here is m. Dimension of mass is m. Why the dimension of what? Acceleration? We have done that before, which is what? LT raised to power minus 2. And when you multiply LT raised to power minus 2 by m, what you are going to have here now becomes what? M LT raised to power minus 2. Therefore, m LT raised to power minus 2 becomes the dimension of force. If you have to just give the dimension of force, you don't need to stress yourself to just write what? M LT raised to power minus 2. The interpretation here now makes you to understand better how comes about what? M LT raised to power minus 2. Now come to the density now. Density is equal to what? Mass all over volume. The dimension of mass still remains as m. The dimension of volume is what? L raised to power 3. L raised to power 3. L raised to power 3 stand on its own is something as what? All over 1. Then if you want to change the sign of division here to multiplication now, the 1 will go up and L raised to power 3 comes down. Therefore you have what? M multiplied by inverse of L raised to power 3. When you multiply this 1 over L raised to power 3 by m here, now what you are going to have becomes m multiplied by L raised to power minus 3. Then you finally have what? ML raised to power 3. And ML raised to power 3 now becomes the dimension of density. Now in conclusion of density, when you multiply m by L raised to power minus 3, you have ML raised to power minus 3 as the density, as the dimension of what? Density. Now let us look at pressure. Pressure equal to a force all over area. Then we have derived the dimension of force before, which gives us LT raised to power minus 2. While that of area is L square. Now we will have it as what? MLT raised to power minus 2 multiplied by L raised to power minus 2. If you look at L we have here now, the power of L here is what? 1. And the power of what? L here is what? Minus 2. If you look at the sign in between this L and this L is what? Multiplication. And when multiplication is given to you and we are considering the power you add, then 1 plus minus 2 is what? 1 minus 2. And 1 minus 2 is what? Minus 1. That is why you see minus 1 here as the power of what? L. Then when you multiply everything here now together, you now have what? M L raised to power minus 1, T raised to power minus 2. And M L raised to power minus 1, T raised to power minus 2 now becomes the dimension of pressure. Now let us look at work, which is the same as what? Work done. Work done is equal to force multiplied by distance. The unit of force here is Newton, while here is what? Meter. And the dimension of force is what? MLT raised to power 2, minus 2. While that of distance here is what? L. When you look at the L here, the power of L here is 1. And the power of what? L here is what? 1 also. And the sign in between this L here and L here is what? Multiplication. And when you are considering what? The power now, it becomes what? Addition. Add the 1 here together with this one we have here now. You have 2. That is why you are seeing power of 2 here on top of what? L here now. When you multiply everything here together now, you have it as what? M L raised to power 2, T raised to power minus 2. M L raised to power 2, T raised to power minus 2 becomes the dimension of work. Now let us look at what? Power. Power is equal to what? Work done divided by time taken. Then the dimension of work done here is what? M L raised to power 2, T raised to power minus 2 all over what? T. And when this T now is going upward now, it will change to what? Minus power of what? Minus 1. That is why you see T raised to power minus 1 here now. Then multiply this by this now, you have ML raised to power 2, T raised to power minus 3. How comes about this minus 3 here now? Take a look at the first T we have here now. it has power of what? Minus 2. Why the second t here now? It has power of what? Minus 1. And the sign in between this t and the other t now is what? Multiplication. Then according to law of indices, when we are, since multiplication is given, when you are considering the power, you also add. Which means you have what? Minus 2 plus minus 1. And minus 2 plus minus 1, you have it as what? Minus 2 minus 1. Minus 2 minus 1 becomes what? Minus 3. That is why you are seeing this minus 3 here on top of what? T here now. Then finally, you have the dimension of power to becomes ml raised to power 2, t raised to power minus 3. Now comes to surface tension. Surface tension is equal to what? Force all over length. What's the dimension of force here? Is ml t raised to power minus 2. Length is what? Is all over L. All over L. And the L here now is going up or now to change to what? Minus 1. Power of minus 1. From there you have what? ml t raised to power minus 2 multiplied by what? L raised to power minus 1. And if you look at it now, what's the power we have here now? Is the power here is 1. Why the power here is what? Minus 1. And when you are considering the power now, you also add, which means you have 1 plus minus 1. 1 plus minus 1 is the same thing as what? 1 minus 1. And 1 minus 1 is what? 0. Then which shows that what? The power of L we have here now becomes 0. And anything raised to power 0 is equal to 1. Which means you have L raised to power 0 now becomes 1. There will be no more L again. Then when you multiply 1 multiplied by m multiplied by t raised to power minus 2, you now have what? mt raised to power minus 2. That is that for that as far as what? Surface tension concerned. Therefore, the unit now, the dimension of what? Surface tension now becomes mt raised to power minus 2. That is the end of today's lesson. Thank you and God bless you.